So here we are back with the using statistical software and summarizing data. And in this section, we're going to specifically talk about planning the analysis. Planning is very important for anything in life and as well as when you're talking about research. So in this section, we're going to talk about extracting the relevant results, missing data and variables and statistics in medical research. So let's start off with planning. So planning, as I already said, it's very important. If you want to be successful, if you want your research to go as smoothly as possible, and you don't want to get confused during the process, so always plan in advance. So planning the analysis in advance after you have collected the data. So first of all, plan the analysis, then conduct it, and that will make your life much easier, and the results will turn out to be the way you wanted them in the first place. So plan the analysis beforehand, and this applies to the whole project and as well as to the individual analysis within a project. So if you're doing a big project, so plan the analysis for the whole project as well as the individual analysis within a project as well. So that would make it very easier and streamlined. And planning the analysis also helps us to keep us on track and avoid unnecessary analysis. So keeping on track, because I have planned that I am going to do step 1, step 2, step 3, and step 4. So I would know that I have completed step 1, I have to move to step 2 and so on. And that would also help me by preventing me from getting carried over with unnecessary analysis, because I would know that this is the plan that I had made and I have to follow it, and the other things are not required. You may be able to make small adjustments, but still the plan would give you framework and a blueprint that what you are going to do and what is the direction which you are going to progress. Moreover, it is also important to check that analysis planned are appropriate. For example, if you are using parametric tests such as an independent t-test or a paired t-test, you should be careful that your data is normally distributed for it. So always important to check that analysis plan is appropriate according to the data and circumstances. Moreover, statistical packages may still perform analysis which are invalid because the sample size or distribution model or design assumptions do not hold, as I already gave you the example. For example, independent t-test, you can apply that on data which is skewed and not normally distributed as well, but that would not be the right way to do it, even though the SPSS or the software would actually carry it over. So you have to be careful that if you're performing any test, it should fulfill the assumptions for it first of all. And you should need to be careful and always keep a log of the analysis so that you would be aware that I've done this, and I've done this, so you would not miss anything out. Now, when you use statistical softwares, they give us a lot of information, and sometimes a lot of that information is not necessary. And it is also a skill and art to identify that which information is most important and necessary. So always focus on extracting the relevant results. So many packages produce lots of output, and most of the time a lot of that is relevant, but a lot of that is not relevant to your situation, your aims, and your objectives as well. So you need to be careful about that. Moreover, it is also necessary to know what is appropriate so that results can be presented later in a concise format. So you need to summarize the data, you need to summarize the results, and you need to extract only those things which are important and which are presentable and which actually correspond to your aims and objectives of your study and your research. So it is best not to simply cut and paste results from a statistical package, because if I give you an example of SPSS, it gives you different tables when you analyze the results, but those tables are not very presentable. So do not just copy or cut and paste them. Transform that data into a more presentable format in the form of graph or a table which is more presentable and extract the results from those tables and just put a little thought process into it. Now, missing data. Now, it is natural, it is impossible to have a research without any missing values because it is natural, it is prone to occur. So all research has some degree of missing data, and it's important to be aware of how the package handles it because it may differ from package to package. So for example, missing data are sometimes noted by a blank cell, such as in Excel, or a dot in a data spreadsheet, such as in SPSS. So it may differ from software to software. And it is also important that multiple regression usually requires data to be present on all variables included in an analysis. So missing values, it is not possible to carry out regression analysis with missing values. So when you carry out regression analysis, it would only carry out the analysis for the number of subjects which have no missing values. So that is important. So that number for which the regression analysis was performed may be lesser than the total sample size that was inducted in the study. Moreover, it is also important that different multiple regression analysis may have different patterns of missing data because there may be one participant for which the variable 1 was missing, and there may be another participant for which the variable 6 was missing. So when you are doing the regression analysis for the variable number 6, the second participant would not be included in that analysis. And similarly, when you're doing for variable number 1, the first participant would not be included in that. So the set of individuals may be different in every regression analysis depending on the variable and the missing values. Now, variables. What are variables? So variable is actually any quantity that is measurable and observable, or it can be measured or observed in an individual, and it varies from person to person. And it is also important that variable is not a quantity which only is a property of an individual. It can also be a property of a thing, of an organization, of any other thing as well. For example, the participants of your study may not only be individuals, they can also be hospitals, they can also be ambulances, they can also be studies or research papers, so it can be anything. Now, statistic is any quantity that is calculated from a set of data. So any analysis that you perform is actually a statistic or a statistical procedure. For example, I wish to perform Kolmogorov-Smirnov test for normality. So that is actually a statistic. I want to calculate average such as a mean, median, or mode. So that is a statistic. So a statistic summarizes the data in some sense and it gives you a result. And the choice of which statistic to use is driven on two basic things, partly by the type of data, such as parametric tests for normally distributed and non-parametric tests for abnormally distributed or skewed data, and partly by the purpose of the study. For example, if I want to find out the association between two variables, I can use a Pearson correlation test. If I want to compare two different groups, I can use an independent t-test. So it depends on two things, the type of data and the purpose of the study. In many cases, several statistics will be calculated from same set of data. For example, in a study, I may be comparing two groups based on their gender, like male and female, and I may be comparing their body mass index with each other. I may also be finding out the association of BMI with height in the same study. So I can carry out several statistics in the same study from the same set of data as well at the same time. So that was all about this part of the lecture, and I hope you learned something new out of it. So keep on watching sqadia.com for more lectures like this. Thank you very much.